My name is Geenen. I'm Technology Partnership with DestinE. I will talk about the digital twin engine, what it is, and where we stand in terms of the development of that component. But first, a little bit of context. So thank you, Catherine, for already painting a little bit the landscape. So when you look at Destination Earth, we have these three entities are responsible for the different parts of Destination Earth. So each is responsible for the core service platform. ECMWF is responsible for the data lake, and ECMWF is responsible for the digital twins themselves. So we have two thematic digital twins on climate adaptation and on extreme events that will be presented after my presentation. But there's also a continuous digital twin that is developed by ECMWF in-house. And obviously, we are also developing a digital twin engine that you see on the left. So I have to rotate this picture a little bit like this to make it map on the picture on the left. So you see the core service platform from ESA, you see the data lake from ECMWF. On the left-hand side, you see, does this laser work? No? You see the Euro HPC system, where obviously the digital twins will run. And you see the data bridge, which is part of the data lake, but it contains software components that are being developed by ECMWF, and are part of the digital twin engine. And it allows you to interact with the data and the models through this cloud stack that is being deployed, co-located closely to where the Euro HPC systems are living. So obviously, ECMWF, in its role in Destination Earth, we're improving the models themselves. We are making sure that they run at high resolution, producing more realistic results. We are looking into combining observation simulation and couple that to downstream application. But in the context of a digital twin engine, the third point is maybe the most important one. It's the interactive and configurable access to all the data, but also to the models and also to the workflow. I think that's really important. So what is a digital engine? So this digital twin engine, we describe it as a collection of Lego blocks. It's a framework, right? It's not domain specific. It's a set of components that can be used in a generic way to develop, operate, and interact with your digital twin. So it's a set of services and APIs. What's important to notice as well is that we have an opt-in model for it. So you can use those components if you want to, but you can also bring your own components and combine them with the digital twin engine. So here we have the complicated picture of the digital twin engine. So let me quickly walk you through it. If you go from the right to the left, you have obviously the users who are interacting with the service platform. And from there, they will interact with services that we deploy as part of the digital twin engine on the data bridge that allows you to interact with the data, but also with the models. Then the models themselves will run on the Euro HPC system on the left-hand side. And if you then move from left to right, you have these models running, producing data, and then we allow also interaction with the data that flows from the digital twins towards storage, but first can be captured as a stream, right? That data flows then from the Euro HPC systems onto the data bridge, where again, you can interact with the data, right? So it's very important to understand that you have both these directions on this diagram where you have opportunities to interact with the data, with the models, but also with the workflow. So where do we stand? Oh, this is also an important point here, that we see that these operations that you have on the service platform, you have machine learning model, you have processing data analytics, and you have your impact models. We foresee that during the life cycle of these different components, they might want to move on these different components, right? So maybe at some point your model grows and you actually have to run it on a HPC system. So this kind of movement of these components over the different components is something that we also want to facilitate. So where do we stand? So for the digital twin engine, we have two workflows that are relevant for the components that I just described. One is on the workflow. So we have these three steps here defined, which we want to finalize towards the summer. So we have, like, the first step is to just be able to do a rapid research prototyping experiment on the HPC clusters. The second step is to have a full research experimentation to be able to do that, and the third step will then be to have a prototype in a sort of a mock-up operational setting. Right, so these are the different evolutions that we're currently developing of the digital twin engine component. The second major activity is around the data handling. Right, so we are currently developing an MVP, minimal viable product, for that part of the digital twin engine, where we have these different evolutions. So we have first going to have a product generation according to the user requirements, where we push data onto a cloud stack, onto S3, where it can be consumed. Then in the next step, we will allow for automatic plotting of generated forecast data. And in the first step, we also allow data retrieval through an API that we call a Polytope, which will allow you to on-demand retrieve data from the system. This is a component that we will deploy in the data stream itself on the Euro HPC system. So the digital twins are producing data continuously. You can tap into that data stream and operate on it. So here we have, for instance, an example where you encode the data into GRIP, but you can also foresee other kinds of operations that you want to perform on a data stream before you potentially eventually want to store some of that data onto disk. So these kind of developments, like this pipeline routing and the selection options, they have different pipelines deployed, the different components, for instance, in terms of encoding into certain formats that you need for your application, they're on our radar and something that we want to deliver towards the summer. Then the other important component is actually the physical hardware, so the data bridge itself. So where are we there? So we are already currently deploying the first data bridge in one of the Euro HPC sites at Lumi. We expect to, by Q2 or so, be able to access the data bridge hardware and then start to deploy components on it. So in the time frame towards the summer, we will have our first sort of experimentation with it. And then towards the end of the year, we will actually have something that we can deliver to